Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this third lecture of Module 7 on effect of geological structure on stability of dam foundation and tunnels. In previous discussion we have elaborated about different types of geological structures like fold, faults and joints. In these lectures we will try to discuss about sedimentary geological structure and structures formed due to gap in deposition or due to existence of erosion. Then we will elaborate about effect of geological structure for stability of engineering structure. In these lectures we are going to elaborate about major geological structure related to sedimentary structures and unconformity, and then effect of geological structure on instability of engineering projects or engineering structure. In this we are going to cover about introduction related to sedimentary structures, then different type of sedimentary structure, unconformity, and then effect of geological structure on engineering project. Friends, as you know, the sedimentary structure is a name indicate is a form due to sedimentation. Before this we have elaborated about different type of structure like fold, fault, joints related to tectonic origin, and fractures and other aspects we have discussed. We have created an elaborate view about different type of structure and different approaches regarding the classification or categorization. In brief, regarding sedimentary rocks, as the name indicate, it is a form due to sedimentation, where in sedimentary processes the three processes effective and responsible for creation of all type of features like erosion, like transportation, like deposition. So the structures of the sedimentary rocks are visible mostly in outcrops of the rocks, and sometimes it can be also observed in hand specimen too. And these features formed by the sediments of the both inorganic and organic origin, or in another words we can say that it is a form by mechanical process or chemical process. The rocks or structures formed by mechanical process in sedimentary environment is recognized as clastic structure or clastic rocks as a host. Then the structures formed by the chemical precipitation or biochemical process is recognized as non-clastic rocks or non-clastic structure. So broadly we can divide the structures in two categories as the clastic structure and non-clastic structure. And non-clastic, the nature, features, geometry, extension of different sedimentary structures depends on availability of materials, depends on texture, depends on the capacity of the mediums which are responsible for carrying out the sediments, and the environment of the basin where these sediments are going to accumulate. Broadly we can divide the sedimentary structures as bedding, the very important structure, then lamination, then ripple marks, mud cracks or sun cracks, then in bottom side shoal marks, groove marks, cast, etc. If we are going to see here, I try to show one view related to this source zone. Due to the source zone here, Here I am taking the example of water. The rivers or flowing water is going to move from here, going to erode material, the erode weathered material, and the weathered material is started moving toward the downwards and finally accumulates. Regarding this class, we are going to discuss about introduction related to sedimentary structures, then categorization of sedimentary structures, then unconformity, and finally effect of geological structures on engineering structures. Friends, as you know, the sedimentary structures is a form when the geological agencies, here I am taking the example of water in form of river, the water is started removing the material from this provenance area and carried out along with the flow of materials transported from this point to allow accommodation in a big depression recognized as basin. So the characteristic of geological structure, particularly belonging to sedimentary origins, depends on the nature of materials released from the provenance or source. It means, in another word, we can say that there is impact of the provenance and then impact of the transportation, extent of transportation and type of transportation, and then environment of basins where the finally sediments are going to show accumulation. Based on processes, we can say that the sedimentary rocks can form by two processes, mechanical process and chemical or biochemical process. The rocks as well as structures formed by mechanical process or physical process is recognized as clastic sedimentary structures. However, the structures formed by chemical or biochemical process is recognized as non-clastic sedimentary structure. In clastic sedimentary structures, we are having one of the important structures like bedding, and the bedding is a very important structure of sedimentation or sedimentary provenance, and the bedding is the most prominent structural features in sedimentary rocks or basin. The thickness and nature of basin depends on the availability of materials and the associated environment, rate of deposition, rate of availability of material, energy condition of medium, etc. The most prominent structural feature in sedimentary rocks is the bedding. It is defined by the texture and composition of mineral grains as well as associated sedimentary environment. A bed is formed by uniform deposition of sediment under nearly constant physical condition. We can say that physical and chemical condition both. The thickness, composition, fabrics and orientation of beds are important parameter for study of sedimentary bed if present in any construction site. If we are going to see a column of sedimentary deposits, then we can see some of the structures located on the surface, some of the structures located within this body, and some of the structures located at the bottom side. So these structures exposed close to surface or nearby surface is recognized as surface structure like ripple marks, mud cracks, etc. And those structures which is recognized or observed in the body of sedimentary succession is recognized as body structures like bedding, like laminations, like different type of features. And those structures located at the bottom side is recognized as soil marks. Body structure and surface structure. If you try to visit any river side and others in point war side or in levee side, you can see the varieties of structures. The surface structures, one of the most common structure is a mud crack. Then we have some biogenic imprints like the footprints of the birds moving in the morning nearby the river or the muddy zones. Then some impressions of different animals searching for the food nearby the river or the water shed area, and others many raindrops and others. Many features are available on the surface of the sediments which incorporate the environmental, natural as well as human made activities. The mud cracks, these are shrinkage cracks found in fine grained sedimentary beds consisting of siltstone and shale, or simply silt, shale, clay, etc., or loose material soil also. The pattern of the cracks may appear nearly rectangular, pentagonal, or hexagonal in geometrical shape. These type of cracks generally form due to expansion and contraction caused by change in temperature condition during drying process of the muddy, silty or shelly materials. These type of cracks indicates about different sedimentary environments, but our target is different. We are anyhow discuss about the different type of structures which are going to influence the stability aspect of engineering structures. Therefore, we are not going to discuss in detail. Beside this, there is a some of structure formed by erosional activity, and some of the structures prominent and responsible for creation of varieties of deposits also. Another important features is lamination. Lamination is nothing, it is a bedding but of very thin in thickness. This type of formations is indicator of very low energy condition of medium, and this generally located toward the top side of the or toward the upper side of the strata or sedimentary columns. Besides this, if we are going to see the beddings, the beddings can be divided in many groups, many types or many classes. However, broadly we are going to divide bedding in two categories: graded bedding and cross bedding. Further, cross beddings we can divide in different categories formed by the ripples under different energy conditions. Graded bedding, as the name indicates, graded, it shows gradation in size and shape of constituent, particularly size. If the lower side of the deposits of the coarser grain, as we are moving from the upper side, there is a finer and finer and finer and finer and finally very fine. So this type of appearance present in bedding we are going to recognize as graded bedding, and it is a form when particles are deposited in gradual variation in vertical direction from coarser at the bottom and the finer toward the upper part due to change in energy condition of material carrying agency. This kind of deposition take place under the slow movement of current, causing good sorting of grain, and graded bedding is a good indicator of top and bottom beds in the sedimentary rocks subjected to deformation or folding due to tectonic stresses. This will be helpful in identifying which one is a top portion, which one is a bottom portion. Cross bedding, as the name indicates, if we are going to see the beddings, we can see some of the beddings can be divided on the basis of curvature, as the zero curvature means linear in nature. about curved in nature, about erratic in nature, if we are going to see the beddings based on thickness, we can categorize the beddings is a thick, very thick, moderate, thin, very thin. Then come to lamination. If we are going to see about the parallelism, in view of parallelism, it can be parallel, it can be non-parallel, it can be non-parallel then converging, it may be diverging. Here I can show this parallel type of bedding, this non-parallel type of bedding, converging or diverging. Then on the basis of relationship also we can divide the beddings as parallel bedding and cross-cut bedding The cross bedding is formed due to migration of ripples, migrations of wave, and these are commonly present in a medium to a coarse-grained sedimentary beds like sand bed or sand and granule mix. The cross bedding, also called as current bedding, or characteristic feature of deposition of sandy a particle in river, deltas or dune formed from the downstream migration of the current ripples and waves. This type of cross bedding generally form here if the ripples are migrating, shifting from here this cartoon is going to explain partially. If in view of time, if this portion is moved and another deposit is here, then this type of arrangement is recognized as cross bedding due to migration of ripples. This cross bedding is very important for determination of paleocurrent, about identification related to energy condition of the currents or flow, and this type of bedding is going to influence even engineering sites also, either belongs to dam foundation, bridge foundation, road pavement or any structure. So extension fractures are prevalent in cross bedding due to extension fractures are prevalent in cross bedded strata, and these structures features are indicator of stream flow direction in river deposits, and wind also responsible for formation of cross bedding. Another agency is also responsible, but in major the wind and water are two which are responsible for formation of current cross bedding. This type of structure is important for paleocurrent analysis because it is formed by migration of waves. Beside this, as we have already discussed, these beddings, here I try to show this graded bedding come in form of here some finer deposits layer. Here try to show some parallel beddings, then try to show some cross bedding of linear curvature, linear nature, then again some beddings of slightly retarded in nature, then some curved cross bedding. Then here at the bottom side we are going to get some depressed and others. These features are recognized as soil marks. These are cross bedding of various geometry, and in this way we are going to see about the sedimentary column. Here surfacial parts decorated with ripple marks, and the nearby here we are going to get some thin layers which is recognized as lamination. The soil marks, score cast and fluid casts and group casts are characteristic structure of sedimentary origin located at the bottom side of sedimentary column. The soil marks are trough-like surfaces with stand-up borders formed by the action of currents or clay beds by unequal loading or by action of organism. It may be biogenic also. We have number of examples in our Vindhyan deposits related to sandy limestone or some sandy surfaces belonging to this lower Vindhyan rocks located in Markundi area. We can see such type of shoal marks and some sandy type of materials located showing shoal marks. These are commonly found in clay stone and shale underlain by sandstone and created by turbidity currents. When a clay bed is scored by erosion due to movement of the wave, suppose here already deposited loose material, when current is going to score this type of material, then in this depression this depression are grouped, so these are later on filled by the material, and if we are going to open this, then it is recognized as karst, otherwise it is original depressions. So such type of features we generally recognize in mechanical rocks, particularly dominated by clay, silt and overlain by sands. Having a pot-like surface, the surface may be later filled by sandy material to form a score karst structure. Beside this, we have fluid karst. Fluid karst is like this type of structures. This also utilized for the paleocurrent analysis or the narrow end of the score karst, and group karst are formed by the filling of groups by sand in shale. Due to flow of water, sometimes what happens, in the material there is a formation of certain groups type of structures, and these group type of structures later on filled by sediments, and such type of fillings we are recognize this. If we are going to open this or get in nature open, then it is recognized as group karst, and this group karst formed by the filling of groups by the sand in shale. All these structural features are used in deciding the top and bottom of the bed if the area is deformed by tectonic forces, where it is very difficult to recognize which one is the top part, which one is the bottom part, or what is the chronological facets of beddings located in area. Beside this, we have some chemically assisted structures present in sedimentary rocks. One is stylite. This is the structures appear in a suture or tracing. In bedding, we have varieties of structures, such type of features located in lower Vindhyan sandy limestone, and these type of features we are recognizing as stylite. These are commonly formed due to migration of some fluid chemicals through the spaces available inside the rocks or inside the unconsolidated materials. It occurs in sandstone also, particularly the sandstone rich in iron oxide solution, limestone and transform part of limestone also you can observe in marbles, finding this type of suture lines. The suture ranges from a fraction of millimeter to maximum of centimeter in thickness, or sometimes even crosses a meter also. We have observed such example in Vindhyans ranging in tunes of 2 meter, 1 meter, half meter, like this. The relief of the stylite surface has teeth-like projections produced by chemical solution under certain pressure condition during the partial consolidation of the sedimentary strata. Another important structures which we are going to observe is a stromatolite. Stromatolite is not mechanically or chemically formed structures. It is formed by the algal activities, and this is sedimentary structure of algal origin, and such structures occur only in limestone. It is formed by assemblage of the blue-green algae by means of precipitation, but not as a product of fossil of organism. And the stromatolite is not a body fossil, but it is the work of algal communities, and we are believing the cyanobacteria is responsible for formation of such type of structures also. But the stromatolite is popular as algae form. Another type of features commonly we observe in field is a gap in deposition. That gap in deposition, sudden change in depositional regime are dominated by erosion is recognized as unconformity. And unconformity can be broadly divided as disconformity, nonconformity, angular conformity. The angular unconformity, as the name indicates, here the overlying and underlying strata having angular relationship. The older is having different parallelism, where the younger having different parallelism. You can see the angular relationship. Here overlying rock is a horizontal almost low angle, where the downward rock is of high angle. Disconformity, when the sedimentary materials are volcanic sedimentary material, here unconformity between parallel layers of sedimentary rock representing a period of erosion or non-deposition is known as disconformity. There is no change, only define the period of non-deposition, which is marked by this zone. Next is non-conformity. Non-conformity, where the igneous or even other primary rocks overlain by secondary or different rocks like sedimentary rocks or even volcanic rocks also. A deep-seated igneous rock body is overlain by sedimentary rocks or lava flow belonging to the igneous rock but of volcanic origin. This type of arrangement of rock layer is recognized as non-conformity. You can see here the igneous rock and overlain by the basaltic flow or rhyolitic flow. Another type of unconformity, that is a feeble type of unconformity, we have paraconformity, and if the strata on either side of unconformity are parallel, but there is a very little apparent erosion, not more erosion. You can see here only change this portion is recognizing about the feeble erosional surface. Here the characteristic of overlying and underlying rock strata, rock beds are almost close to each other. Another features we are going to observe as the overlap, onlap, offlap and others. The overlap is the younger beds is going to cover about the older bed. Here older bed, younger bed going to cover, and this type of features I have collected from some source belonging to this rock source about some website. Another aspects we are going to discuss about the effect of geological structures. So here, before discussing this, we are going to summarize. We have already discussed about faults, fault, joints, then unconformity, then some sedimentary rocks like bedding, ripples marks, shoal marks in beef. To develop a platform or a broad view about different type of structures for our purpose. Now in general we are going to elaborate further about the impact of these structures or engineering structure. Effect of geological structures, probably the probable problem facilitate the estimation of cost of treatment in the planning and design stage and delayed or expected in completion of the project. The problem that may arise due to different type of geological structures in engineering development work, such as a dam, tunnel, road, railway track, bridge, building foundation, etc. Faults are obvious features when visible in surface exposure of rocks. We are having varieties of faults, and generally we are going to encounter fault and faults in field. Particularly faults, the repetition of bed in ground subject is a criteria for identification of beds. Here you can see this type of folds. If we are going to cut this, then we are going to get here suppose A bed, B bed, C bed. Then again we are going to get here A bed, here B bed, here C bed, A bed, B bed, then A bed, B bed, C. Here repetition, here. Means an anticlinal fold is commonly segmented by extensive joints in particularly in crustal zone. If we are going to see folds here, then the number of joints and fractures located at the crustal zone area, this zone area, and some places associated with faults also. Sometimes fold, this part shifted, and showing some fault also in folded area. In such, the presence of folds in a dam site may create foundation problem including leakage, requirement of treatment, grouting, different type of wire meshing, etc. So, the fold present below the dam foundation is creating lot of problems depending on the part of fold located below. Suppose here the fold crest is located here, it may cause number of problems. But if the limb part is exposed, it may be supportive, it may be destructive. We will discuss in our future classes. When such, so resulting filtration and others, when such harmful features occur in slope cut along road also for development of road, it may create problems of instability concerned to rock slide and various type of instability related problem. Similarly, the synclinal fold also play an important role in sorting and migration of water through the planes of discontinuities or the planes of interface when present in foundation of dams or reservoir peripheral area. This may also create lot of problem concerned to seepage and reduction in strength and durability, particularly in case of the earth dam, it causes piping and others. If the excavation, particularly in case of the tunneling or creation of the dam foundation, if the excavation going to puncture water bearing beds present in synclinal fold, that it creates lot of problem in form of development of artesian or confined aquifer system. That confined aquifer system is going to push the structures, number of rocks, and going to make the whole site disturbed in nature, causing enhance in price of the project and delayed in work. This problem is of significantly important in tunnel construction because of the flooding in tunnels and creating lot of problems concerned to delay and concerned to enhance in cost of project in form of costly treatments and others. Then the erosion of soft materials along the fault and fold crest is also problematic. Among different geological structures, taking the presence of fault is a very crucial and very problematic because the fault is consisting of shatter type of rocks like fault gouge others, and the fault gouges are more susceptible to erosion, causing lot of problems related to weakening of the strata lying below the foundation of dam or below the pavement of road or below the foundation of bridge or below the foundation of building. Besides this, the presence of shear zone is a very critical problem in stability aspects of dam or any structures because the shear zone consisting of deformed, complicated, fragile rocks requires careful treatment and preparation, costly treatment like dental treatment and others for minimizing the problem. In case of the active faults is very problematic due to lot of effect or impact on the nearby rocks, continuous crushing, powdering and deforming the rock associated with the active rocks. This active rock is liable to initiate further earthquake movement and deformation of material very fragile in nature that is very harmful for development of any engineering project if located near or close to construction site. Therefore, in such zones, the recommendation regarding the heavy structures is not possible. Another, we have varieties of structures, joint, fractures and other features which directly or indirectly going to influence the stability aspects of engineering project. We have already discussed about the role of joints in categorization of rock mass, and based on the joint frequency, joint aperture, joint number, joint conditions, we have calculated about the strength based quality response of rocks. So you all are very familiar and about the role of joints, fractures and other features like bedding, lamination, mud cracks, sun cracks and others which are directly or indirectly going to influence the strata lying below the dam, below the road pavement, below the track of railroad and below the dam foundation, below the building in general. Similar to the surface structure, the underground structures also feel lot of problem due to presence of foliation, lineations, fractures, joints, etc. that result about the overbreak requires a lot of precautions regarding the support system to provide suitable support and stabilize the excavated opening. So we will discuss in our future classes detail about the role of geological structure in general for stability or ground control problem related to tunneling. Friends, these materials I have prepared with help of book Engineering Geology written by Gangopadhyay. Yes, this book is a very good book and written for the engineering applications by Dr. S. Gangopadhyay. The book containing page 12549 thick book, and partial support I have taken from Engineering Geology written by Bell FG in 2007 having page number 12551. Then partial support from the textbook of Engineering Geology having page number 1495 and written by Kashabolu MC in 2016. Friends, in these lectures we have elaborated about the sedimentary rocks, and sedimentary rocks have varieties of structures formed by either mechanical or chemical or biochemical process. The beddings and laminations are the body structures as well as some shallow surface structures where the ripple marks as well as lamination, mud cracks, bird footprints, raindrops, animal footprints, etc. are the surface structures. Sole marks, groove marks, flute marks are bottom structures. This also can be utilized for academic geological purpose to identify top and bottom part of deformed structure, deformed folds and others where the identification is generally difficult. For geological point of view, from engineering point of view, these structures are going to participate in stability aspects of engineering geological structure. The bedding can be divided as graded bedding, cross bedding and varieties of cross bedding, and these formed by the migration of waves. The characteristic of bedding depends on the environment, source area, provenance, about the energy condition of the medium, etc. And the unconformity is representing period of erosion or non-deposition, preserving rock strata or preserving sediments also, recent quaternary deposits, and we have varieties of unconformity observed in Vindhyan, in Kodafa, in many sedimentary basins. All kinds of structures principally influence the stability of engineering structures such as a dam, road, pavement, bridge foundation, building foundation, airport foundation, airport pavement, railway track foundation, etc. Dear friends, in this class we have elaborated about different type of structure, particularly sedimentary structure, classification of sedimentary structure in brief in form of bedding, lamination, mud crack, sun crack, ripple marks, bird footprint, animal footprints, and then soil marks, different type of bedding such as graded bedding, cross bedding, and we can also further divide the cross bedding based on the depth of cross-bedded material in form of the different set, co-set, four-set and others in detail for geological academic point of view. Here our main objective to see the basics of different geological structures which are going to influence the stability of engineering structure. Beside this, we have discussed about unconformity and classification unconformity like angular unconformity, disconformity and nonconformity and paraconformity. These depends on different arrangement of rock beds with respect to overlying and underlying strata. Then we have elaborated about the influence of geological structure, all geological structures in general, which we have already discussed on engineering geological project in general. In next class, we will discuss about the effect of bedding, effect of faults, effect of folds on dam foundation, then effect of these in further next class in ground control aspects of tunnel. Thank you very much.